Hello, I'm Dr. Harper. This video is in Management of Operations, BUSN 6630, Section 1, Spring 2021. It's the homework number 4 inventory video. So let's bring up the homework. Now the homework questions here, I start with just constant demand, consistent constant demand of 50 items a week. And I just ask for conversion for the inventory period, lead time, order frequency, and turnover rate. And so it's just a given the inventory policy. So in order to work this one, it's pretty straightforward in just saying, okay, well, it's going to be conversion from our demand is items per week. Let's just put this up here. Our demand equals items per week, 50 items per week. And then our ROP is given in this policy here of 35, okay? And then our lot size Q is given to be 260. So we have these values, okay? And these are just items and items. And so I'm asking for the inventory period in months, and notice our demand is in weeks, so there's going to be some conversion. And let me just emphasize, again, strongly encourage people, first, take the demand and go to years. And so it's 50 items per week. It's 50 times 52 weeks in a year. That's going to be items per year. And start with that. And then if you need months, then you divide this number by 12. If you need quarters, you divide this number by 4. That kind of thing. And then for each one of these, you'll have the different equations. For the Q equals DT, ROP equals lead time. Now the safety stock is 0. So here we're just using the demand equals, ROP equals demand times lead time. In other words, the ROP here simply equals demand times lead time. That's all it is. And for Q here, we want the inventory period. We want the order frequency. So we will use Q equals D times T, which is equal to D over F. So we use these equations, you just pull out the different, and use the D here. Notice D has to have the, equals. D has to have the right time units, if it's months, weeks, or quarters. Okay? Oh, and also the turnover rate equals 2F. 2 times the frequency. Okay, so that's all I'm doing here. It's just going through the relationships here. Hopefully everyone can get that. Now down here, I have concern was expressed over the zero safety stock. Discussion included inquiries about the changes in the inventory policy and the turnover rate due to increase in the safety stock. If the safety stock was increased, then how many of these statements are correct? Well, each one of these is the reorder point, lot size, turnover rate, inventory period, and so essentially you just say which one of those will be influenced by safety stock. If the safety stock changes, which one of those will be influenced? Is it increased, decreased, or unchanged? Okay, again, that's just looking at the relationships within the equations up here. Okay, part B. Now, again, I still have a constant demand rate of this items per year. Actually, we can come down here and say our demand rate equals 2,600 items per year. So I start with a year. Okay. Now down here, this is a quarterly report. So we have our C right here. This is equal to C. That's our item cost. Down here we have our average inventory and our total inventory cost. Okay, so this right here equals, let me just say, equals the total inventory cost. Okay, so then what then would be our carrying cost then? Well, this is in dollars. So I used I to be the indicator of carrying cost per dollar, items per dollar per time period. Well, this is per quarter. So here I have the average inventory and the total carrying cost. So I have the carrying cost per my average inventory, but then what's my carrying cost per dollar per year of my average inventory? So on the average, I'm carrying $42,000 worth of inventory. It cost me $7,560 to carry it. So essentially that'd be $7,560 divided by 42,000. See, and that's going to be my cost. My cost per dollar per quarter. Again, be careful of the dollars and the quarters. Now, if I want my carrying cost per item, I multiply by the C, 150. And that'll be my cost per item per quarter. But then do I want a year up here? Let's see here. Which inventory policy that satisfies? And notice it's a continuous review. So we want ROPQ. Okay. Down here, what would be the total annual inventory cost? So what is Q? So we want here, we want ROP. Do this again. ROP, and we want Q. But notice up here it says the inventory policy that would minimize cost. So we want EOQ here. But we don't have EOQ because it says the information in their last quarterly report was collected and reported below. This information is to be used for future planning purposes. So this is going to determine our unit costs. So there's our unit carrying cost. Our unit ordering cost down here, that's equal to TOC. I said this wrong. This is TCC, sorry. Carrying cost. TOC down here. And so our unit ordering cost simply will equal our total cost 78960 divided by 80. That's going to be the cost per order. And that's going to be a very large number. So I picked it to be a large number so that the numbers will work out down here. Anyway, and sometimes, depending on how inefficient your purchasing department is, sometimes your ordering cost is very large. Okay, anyway, so that's that. So there's our unit costs up here. And there they are. And that's what's used for the EOQ, to get the EOQ. Now the ROP would simply be your demand times the lead time up here. Well, that's given up here. Lead time is equal to 1.3 weeks. And the safety stock is going to equal 12. Okay. And so we have the lead time, we have our demand, lead time, safety stock, so this we can calculate our ROP. But down here we have our ordering cost and carrying cost here. And then we have our demand up here. That can determine our EOQ. Because remember, the EOQ then, EOQ will equal the square root of 2 times D times C sub O over C sub C. So here's our demand. Here's our unit ordering and carrying cost from the table here. Just comes from the quarterly statements. Okay. Okay. And then down here, what would be the total annual inventory cost, which is the total annual inventory cost is the carrying and ordering cost together. So this was the ordering cost from last year, but if we're changing to EOQ, then we have to calculate the ordering and carrying cost here. Total inventory cost will equal total carrying cost plus total ordering cost. So we have to calculate those things. So if you put these in Excel, then you should be able to calculate them from the quiz. The quiz really went through the mechanics of calculations. Okay, and so the whole purpose of Part B here is just pulling them off of quarterly statements and just finding these unit costs. Okay, let's go on. Part C here. Now I move to normally distributed annual demand with a standard deviation. So now I'm moving to a stochastic demand. Okay, and in the stochastic demand, now we have to come up, we have our mean, and standard deviation, but this is the annual. Okay, so this is the standard deviation, the mean per year, and the standard deviation per year for this inventory item. So we still have the lead time. So here I have demand follows a normal distribution with a mean of 8580 items per year. Let me just say 8580, comma, and 80. Well, let me do it this way. The mean equals that, and the standard deviation equals 80. And these are annual, so per year. Okay, and then we have the lead time equals 0.3 weeks. And the inventory period equals 2 weeks. So that's the information, the header information. That's from the header. Down here, what is the inventory policy for stock level 8%? So now we have to go back and think about, now notice this is continuous review. So we want ROP here. We want the ROP, comma, and Q. Okay. Well, we want it down here too. So the idea here is, if we come back up here, ROP is going to be equals our mean times our inventory period plus our statistical safety stock. And that's going to be a Z times the standard deviation times the square root of the lead time. So we have to go back to these equations and pull these equations off. The Q simply equals the mean times T. Well, this is the mean times the lead time. Forgot that. Okay. So we have the mean, we have the standard deviation, and we have the lead time is in weeks. So in order for this to work, this mean is in years. The standard deviation is in years. The lead time is in weeks. And so if we're using the mean here, which is in years, the lead time is in weeks, one has to be, well, we want the ROP, the time units have to be the same. Okay, so we can transform years to weeks or weeks to years. However way you want to do it, you have to be very careful to do that. Now, notice since the lead time is in weeks and the inventory period is in weeks, let's just change this demand to weeks. Okay, so what that would be, it's going to follow a normal distribution where it's going to be the mean is going to equal 8580 divided by 52 weeks. Okay, so that's my demand per week. What's my standard deviation per week? Well, that's different. Here the standard deviation will equal the square root of the variance, okay, which is 80, which is 80 times 80. That's the variance. But that's the variance, annual variance. So you divide the variance by 52, okay, to get the variance for the week, and then take the square root to get the standard deviation. Okay, and so that's how you would transform the standard deviation. Now, I say this here, you think, wow, where did this come from? Let's go back to the Canvas and come down to my website here, mdharper.com. We open this up under Operations Management. We come down here under the time conversions. This is explained in video number 2. It's easy to miss, so that's why I went ahead and did it. But then that is explained here on how to go back and forth with standard deviations. That's different than the mean, because mean is linear, is monotonic and linear function, but standard deviation is not because it's a square root. Okay, so that's how that's done. So now that we have the mean and standard deviation, and now we can just go through the equations. Go through this equation for ROP, this equation for Q. Okay, now down, and also the Z here for 8%. Hopefully everyone can get that. The Z then will be the normal, standard, inverse. 1 minus 8% is 0.9, what is that, 92? Yep, 92. And that'll give you the Z value because it's cumulative. You want 8% in the tail, this is cumulative. So that's the standard inverse. Whoops, I see I'm going so fast here that a lot of times, make sure I don't make mistakes here. So I would catch them. Okay, so listen to the whole thing. So like there, you'll go do IV, it's not going to work. Won't recognize it. INV, it will. Okay. So there you have everything for that. Oh, now if the variance of the normally distributed demand is increased by 24%, then one thing changes, and that is the standard deviation. So this means the Q doesn't change. Okay, so this Q is not going to change, but the ROP will change. And the only thing will change is that number. So what will that number be? Well, let's just do it down here. Standard deviation equals the square root of, remember, it's going to be 80 times 80 divided by 52 per week. Okay, but I'm going to increase it by 24%. So let's back up here. I'm going to increase the variance by 24%, 1.24. Whoops, 24. Okay. So now I'm increasing the variance by 24%. Now this goes into this equation up here for here. So the only thing that's different, so the Q is the same. The only thing different is the ROP. Okay, so that's how you do this one. So a lot of this is on converting standard deviation, so you got to be careful. Okay, part D. Company D conducts 10 events per month. Okay, we're talking about events. To promote prototype products for companies in a specific area. The demand for the product is randomly distributed and assumed to follow normal distribution. Over the last 5 months, they have estimated a long cost of $45 per item, short cost of $3.25 per item, along with an observed demand for each event given in the table below. Okay, so 5 months, 10. So we have 50 items here. And so based on these data, was the optimal lot size for the next event. So this is a single period. So the idea here is you need to get, well, remember the equation for the single event. Let's bring them up here. Simply, just to recall, remember the alpha is going to equal the long cost divided by the long cost plus the short cost. Okay. Oh, geez. Long cost plus short cost. There we go. Okay. And then the Z then will be the normal standard inverse of, that's going to be your 1 minus alpha. Okay. And then EOQ will equal the mean plus your Z times standard deviation. Oh, so alpha is given to be, can be calculated from the 45 and 35. We have 45 here. In other words, this is going to be 45 divided by 45 plus 325. There's our Z. Okay, there's our alpha. Alpha goes into here to calculate our Z. Z goes into here. We need our mean and variance. Okay, well, it gives you all the numbers here. So let's bring up Excel, and hopefully everyone, we've done this enough. Hopefully everyone is comfortable with this. Okay, I will come here. I will highlight all of these. Control C to copy. Bring up Excel, and I'll put it right here. Control V to paste. Control C, and I'll paste just the values. There they are. I need the mean and variance. Well, the mean, let's enlarge this so we can see what we're doing here. So you can see what we're doing. There we go. And I need the standard deviation. This is just the average of all these numbers. There we go. I'll go ahead and do it. This is the standard deviation. It's the P. Notice I have a P, or population or sample. This is the population standard deviation of all these numbers. And there you go. So now I encourage you to actually go into Excel and do this just to see how to do it. So I'm easing into using Excel here. Okay. So now we know what our mean and variance, mean and standard deviation are. And you put them in here to get the value. Now, if only one cost was increased, which would one cost, either the short or long, which would cause a decrease in the optimal lot size? The short cost, long cost, or none of the above. Oh, okay. Well, what I suggest, the best way to do that is put this in Excel, get it, and then increase the long cost and see what happens to the EOQ. And then increase the short cost and see what that happens to the EOQ. That's the easiest way, just trial and error. Another way to do this is to rearrange this. It's 1 divided by, is divided through. This is going to be 1 plus short cost divided by the long cost. And so right here, remember, if alpha increases, that decreases the Z. Okay, and so as alpha increases, Z decreases, which EOQ decreases. It's inversely related. So how does alpha change? When the short cost changes in the denominator, or the long cost changes in the denominator of the denominator. So when you increase that, so it's just a relationship thing. And I'll leave that, that's 2 different ways of doing it. I'll leave that for you to do it. You can either set it up in Excel and manually just do it, simulate it, or you can see right here, alpha will be inverse related to EOQ. Okay. Let's go on to the next one. Part E. Okay, wholesale E that has been assuming constant rate demand. Notice stochastic weekly demand. Weekly demand. Now we're in the weeks again. Since this has caused problems, it was decided to investigate stochastic demand inventory policies. The lead time is 2.2. The inventory period is 4 weeks. Were known, but a 12% stock out level was chosen to consider an inventory policy in their periodic review system. Aha. Now with a periodic review, stochastic demand, we're looking at the base stock level. Base stock level calculation. In the base stock level, there's where you have to add both these two together, the lead time and the inventory period together, with a 12% here. But you need the mean and standard deviation again. The mean and variance and mean and standard deviation. They requested weekly demand and received the histogram of weekly demand. Upon reviewing the frequency distribution, the weekly demand was assumed to be normally distributed. Well, it's symmetric and it's normally distributed. Sure. That's definitely close enough. So that is normally distributed. So the assumption is reasonable. Now the question is, so base stock level. Well, we're trying to calculate the base stock level. Well, what is it? Well, it's going to be the mean times the T plus LT, okay, plus the safety stock, which is Z times the standard deviation times the square root of T plus LT. There we go. So let me just take this back here. Let me bold this, center it, and make it bigger to emphasize it. That's what we're trying to do. Okay. Now notice up here, the lead time is 2.2, the inventory period is 4. We have T and LT in weeks. We have T and LT in weeks. We have the stock out level percentage here. So there's two things we have to do. One is to determine the mean and standard deviation. The second thing is a Z. Let me just put it up here. Z will equal, again, normal dot S dot inverse of 1 minus the 0.12, whatever that is. There's your Z. Now, what's the mean of variance? Okay, it comes from the histogram. Okay, in the lecture, let me pull up the lecture. I think lecture number 2. Lecture number 2. If we come down here, let's see here. I think it was ding, 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 ding. Let's see, this is not it. Let's come down here. Here it is. On page 5-8. This right here determines how to do it. Okay. And then down here, I illustrate it. I illustrate how to do it. I think I also illustrate it in the video, in the lecture video. But now we're going to be doing it. So let's do it here. Okay, so the idea, let's bring up Excel. Let's bring up Excel again. Okay. Let's just create a new one here. And we have, here's the value of the weekly demand, 500, 600, 700, 800, 900. Is that all? I see. Let me pull this back up here. 900 is all we have. Yep, just have 900. Now let's type in the frequencies. This is 12. This is 54, 98, 72, and 14. There they are. So this is the X. This will be the frequency. Okay. Good. From that, we can get a variance and a standard deviation. Okay, let's sum this. And there it is. Just to let's center all this stuff and make it a little bit more readable with Arial. I like Arial. Okay, from this, let's get the probability. That's going to equal the frequency divided by the total frequency. F4 to fix that. Okay. Whoops, don't need that. And then we just copy this down. So there's our frequency. Now if I copy the sum, it's going to sum to 1 because it's a frequency distribution. Okay, now remember how we do this? X times P equals X times P. We sum that. I mean, we do that. And then we sum it. There is the there's the mean. That's the mean. And then we have X times P. That equals X times X times P. And then we do that all the way down. And we sum that. Okay. Then over here, the variance will equal the sum of the squared values minus the mean squared. This times this. And so there is our variance. Then our standard deviation is the square root of the variance. And there it is. So that's how you get the mean there's a mean. That's how you get the variance. So it's not hard with Excel, and if you know how to do it. But it's not obvious. Okay. Now we have everything to calculate this. Okay. And then since the stockout level was chosen, different stockout levels can be considered. As the stockout level increases, what happens to the base stock level? Again, it goes back to this. If the stockout level increases, if this increases, then what happens to Z and what happens to the base stock level? Again, these are relationships. You can either do it manually or you can do it through the relationship in the equations. And wow, that's all I have for the homework. I hope this helps. And essentially, if homework is an extension of the video, a lecture video, is I took what I said in the video and actually showed how to do it and explained it. That's all I have for now. I hope this helps. And between now and the next time I see you, I want to urge everyone to stay safe, to don't take anything for granted, stay healthy so you can keep learning. So that's all I have.